Hello everyone, welcome to our lecture on ordinary differential equation. Today we are continuing with the formulation of ordinary differential equation. And now we are in a position to take up the question of civil services examination. The question says that we have to find the differential equation of family of circles in the xy plane passing through point -1, 1 and 1, 1. This question was asked in IAS examination 2009 for 20 marks. Before I start solving this question, it is pertinent to understand that what is the equation for this. Most of the candidates start writing the differential equation. They write the general equation for circle, that is this. Definitely if you will solve through this, you will get the same answer. But here it is explicitly mentioned family of circle. This is the general equation of circle. So we cannot start with this equation. Also, some of the candidates tried it like this. At 2 points fixed A and B of radius R. This is the general equation for the fixed values. What we have to do, we have to first write the family of circle. So then only we are going to get the full marks, because question is explicitly asking us to do so. So the equation of family of circle, if we take the circle as passing through 2 points, say x1, y1 and x2, y2 at point A and point B, then its general equation is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus lambda, because that is passing through the points, so we will take the slope. So this is going to be y minus y1 into x1 minus x2 minus of x minus x1 into y1 minus y2 is equal to 0. So this is the general equation, and here we are given the points. Here the x1 we can write as minus 1 and y1 is 1, x2 is 1 and y2 is 1. So if we plug this value in this one, we are going to get the equation of family of circle. So if we put here, in place of x1 we put minus 1, so this becomes x plus 1, and here it is minus 1, so this is, and here y1, y2 value is 1, 1, so we can write it y1 into y1 minus y1 plus lambda. Here again y1 value is 1, x1 minus x2, x1 is minus 1, x2 is 1, so minus 1 is minus 2, minus of x plus 1, because we are having this one, but this amounts to 0 because y1 and y2 are same, so this is 0, we subtract it, so this gets nullified. So finally we get our answer for this equation, x square minus 1 plus y minus 1 whole square minus of 2 lambda y minus 1 is equal to 0. So we have formulated the equation. All we have to do now, we have written the equation as per our procedure. Now we are known that the lambda is only one constant here. The arbitrary constant, so we have to eliminate lambda. So all we need to do, we just need to differentiate it once and eliminate lambda, and we will get our differential equation. This is the procedure. So now I will differentiate equation 1 with respect to x. When we do so, we get this is as 2 of x plus 2 times y minus 1 y dash minus of 2 lambda y dash. So from here we are getting the value of lambda. What is the value of lambda? Lambda value is x plus y minus 1 y dash divided by y dash. So we have got the value of lambda. Okay, so if you put this value of lambda in equation 1, we are going to get our answer. Alright, so now I am going to put the value of lambda in equation 1. So put lambda in equation 1. So this will be x square minus 1 plus y minus 1 whole square minus 2 y minus 1. Now I am going to put the value of lambda. This becomes x plus y minus 1 y dash divided by y dash is equal to 0. So this is our equation. All we have to do now is simplify this and we will get our result. So we will start from here. We write it as x square minus 1 plus y minus 1 whole square. You see it is in denominator. If we send it here, we can write whole as y dash, and if we take this whole on the right hand side, we will get this as 2 times y minus 1 into x plus y minus 1 into y dash. Now we can see here y minus 1 into y minus 1 is y minus 1 whole square. So we can take this one on this side. So when we are doing it, we can write it that we will open it up. Y square minus 2y plus 1. Here it is how much? 2 times of y1 whole square. And this is 2x y minus 1. So we can further simplify this one. When we will do that, it becomes x square minus 1 plus y square minus 2y plus 1. If we just do further simplify, this becomes 2y square minus minus becomes plus, this becomes 4y, and this becomes minus of 2 y dash is equal to 2xy minus 2x. So what all terms get cancelled? This gets cancelled, this gets cancelled. We are remaining with x square minus y square plus 2y minus 2 y dash is equal to, you can write it as in similar fashion. So this is the differential equation. So we are having only one arbitrary constant, so only the order we can see is here 1. So we are very much clear with our concept of order and arbitrary constant. So with this question particularly, this is a 20 marker question. We have to be very vigilant about how to go about it. I have already mentioned which equation, general equation not to be taken, other equation not to be taken. Only equation that you should use in examination is the equation of family of circle. Alright, so now we are going to take up the next question. So this is the second question for this session. What is the question saying? We have to find the differential equation of all circles in the xy plane. This question was asked in IES 2017 for 10 marks. In the previous question, which was asked in 2009, what it was asking? It was asking for the family of circle in xy plane and 2 points were given. Alright, so there we were having only one arbitrary constant. But here the question is same, but its way of asking and its demand is different. Now, if we write the equation of circle, here only changes we are having 3 arbitrary constant because it is mentioned in general terms. You could have done it by x square plus y square plus 2gx plus 2fy plus c is equal to 0. That is also the general format. If you do by that method also, there also we have 3 arbitrary constant and we will get our value right. We can try it yourself. I'm going to prove it, find the solution through this method. So equation of this circle is x minus a whole square plus y minus b whole square is equal to r square. So this is the equation of circle. Alright, this is the first step that we have to write down the equation. Now we have 3 arbitrary constants. So how many times we will have to differentiate? We will have to differentiate thrice. So let's get started with this. So now I will differentiate equation 1 with respect to x, and when we do that we are going to get 2 times of x minus a plus 2 times of y minus b, y dash is equal to r is radius constant, so its derivative with respect to x is 0. Now I can further simplify it. I can see you are having 2 on both sides, so I'll erase it and I can call it as equation 2. If I differentiate equation 2 with respect to x again, we will get how much? Dx by dx is 1. I am keeping this one as constant, y minus b constant. So this becomes how much? Y double dash plus, now y dash is constant. So what is the derivative of dy by dx? So this is again y dash is equal to 0. So what we get here, we get as y minus b, y of dash is equal to minus of 1 plus y dash whole square. Okay. Why we have done so? Because we will be using it later onwards. Now I will call my equation this as my equation 3. Alright. So now I am going to differentiate my equation 3 with respect to x, and we will get this as, see here, not here, we are going to use it. So t, this is a constant, so its derivative with respect to x is 0. This is 0. This is again how much? Again I am going to keep this one as constant. So y dash double dash, so this become y triple dash plus, if I take the derivative, this become how much? Y dash, this is again kept constant, y double dash. Again this is y dash whole square. So if I take its derivative, it will become how much? 2 y dash 2 y double dash. So that is equal to 0. So from this equation I am going to put y minus b, y triple dash is equal to minus of 3 y dash y double dash. So this is my equation 4. Now this part and this part, we are seeing y minus b, y minus b. So I will eliminate my b constant, and when I am doing so, I will write it on the upper portion here. So I will differentiate this one. So this become y minus b, y double dash, and this is in the denominator. I am actually dividing this one. This is y triple dash. So this is 1 times y dash whole. This is minus of 3y dash y double dash. So here we have actually arrived very close to the answer. But all we have to do, we have to write in the standard format. So this one and this one get cancelled. So we can take this one over here. So y triple dash into 1 plus y dash whole square is equal to 3 times y dash y double dash. So this is again the square of it. So if I am going to write it in another format, I can write it like this: 1 plus dy by dx whole square into 3 dy by dx into d square by dx square whole square. So what we are saying here, the order is 3. So we are actually initially started with 3 arbitrary constants. So we have the third order differential equation. So this is our answer for this question. So I would like to make an important comment in this regard. No matter whatever be the question format, if we are going to use our fundamental concept to order an arbitrary constant, and in the general form in which it is asking, say if it is asking general equation, you can write that only. If they are asking you family of curve, particularly with regard to circle or anything, would be parabola, hyperbola, ellipse, anything of that sort. So if we are very clear with our fundamentals, we are in a very good position to solve question with crystal clear approach. Now I am going to take another question and the last question for this session. Okay, so this is the third question, which is saying that we have to find second order ordinary differential equation from which ex and x square e to the power x are solution. This question was asked in Indian Forest Service 2009 for 10 marks. As I have promised that I am going to also include the topics of Indian Forest Services, so at the appropriate place I will be coming with the questions that I will ask in the Indian Forest Service examination also. So we have to formulate differential equation and we have to find the second order, it is explicitly mentioned. So we have to start with y is equal to, say, arbitrary constant c1 e to the power x plus c2 x square e to the power x. So we are having our equation, this can be written as 1. So we have formulated the equation, we have to differentiate it twice because two arbitrary constants are there. So now I am going to differentiate equation 1 with respect to x, and we will get y dash is equal to c1 e to the power ex plus c2, and if we differentiate it, if we keep x square constant, so e to the power x differentiation is e to the power x. Now I am going to take e to the power ex as constant and I differentiate x square, so this is our answer. So if we will rearrange this term, we will get certain things in terms of equation 1. Let us see. If we write this as c1 e to the power ex plus c2 x square e to the power x plus 2x c2 e to the power x. This one and this one. This is y from equation 1. So we can write y dash is equal to y plus 2x c2 e to the power ex. This is an important point because from here we will eliminate c2. So that is why I have underlined this one. Now I can call this as my equation 2. Now I will again differentiate, and this time equation 2 with respect to x. We get what? Y dash with respect to x is y double dash, y is equal to y dash plus, if we take 2c2 as common and if we differentiate it here, see, I am going to take x as constant, so derivative of e to the power x is e to the power x. Now I am going to take e to the power x as constant and differentiate x, so that is 1. So I am getting y double dash is equal to y dash plus 2c2, I can take e to the power x common. Now I am going to use this c2. I can say c2 is equal to y dash minus of y divided by 2x e to the power x. So I can use this here. So y dash double dash is equal to y dash. In place of 2c2, I can write y dash minus y divided by 2 will get cancelled. Alright, and here we have to mention e to the power x. So e to the power x, e to the power x get cancelled, 2 and 2 get cancelled. So we get y double dash is equal to y dash plus y dash minus y divided by x into x plus 1. Okay. Now if we are going to further simplify, we are going to get our answer. So this becomes y double dash is equal to y dash plus y dash minus y divided by x into x plus 1. So we can take this as x as common. So here we can write it as y dash is equal to x plus 1 minus of y x plus y. So if we send this here from the denominator to numerator on this side, so it becomes x y double dash is equal to x dash 2x plus 1 minus of y x plus 1. So we can write it on one side, our differential equation. So this is our answer. But we have to also say that y dash is dy by dx and y double dash is d square y by dx square. Or we could have written in terms of this only. So this is our final answer. So with this we end this session. Thank you for watching and please like, share and subscribe.